Let's talk about tic-tac-toe counting. It was one of the easier problems in the set, perhaps the easiest problem in the set, but it's still worth talking about. The problem is all about the game of tic-tac-toe, a simple children's game that probably everybody has played. It's played on a 3 by 3 grid, and players alternate placing X's and O's in the grid. If any player gets three of their symbol in a row, they win and the game ends. So the problem was, given a list of tic-tac-toe games in progress, for each one, find how many ways from that point forward X can win and how many ways from that point forward O can win. Some basic tricks for solving this problem. First of all, there are 9 cells on the board. So if we use the digits 0, 1, and 2 to represent an empty cell, an X, and an O, then we can compute an integer key for any board position by using base 3. And it turns out that there are fewer than 20,000 board configurations possible. So that gives us the possibility to play all possible games up front first and store the wins in an array. Then, for every input, all we'll need to do is look in that array rather than replaying the game from that point over and over, which would probably give us time limit exceeded. So here is a main program. The first thing we do is set up our wins array. We initialize it to all -1 because any unreachable board position, -1 is the right answer. Pre-compute the powers of 3. That'll help us compute our base 3 and count all the wins a priori from an empty board. And then when we read the input, all we need to do is convert that input into a base 3 number and then look into the wins array, print that out, and that's all we need to do. And here is how we will play all possible games. First of all, if you take a look over on the right, you will see a simple little method that'll simply determine if a player has won. So the first thing we're going to do to count the wins is determine if we've already done it. If wins is not -1, then we've already been this way before. We don't need to go any further. But if wins is -1, we haven't seen this board position before, and we need to figure out how many wins each player has. So first, we'll check to see if the opponent has won, because if the opponent has won, the game is over. We can't place our mark. So we'll check all 3 rows, all 3 columns, and both diagonals. And if the opponent has won, then from this point forward, there's 1 win for the opponent and 0 wins for us. Otherwise, we're going to take a look at all 9 board positions. And if it's empty, place our player's mark there, compute a new key, count the number of wins from that point forward, and tally up the wins. And that's all there is to it.